Hello, welcome back to my YouTube channel guys. Today's question is find minimum time to reach last room, the second part of it. And the first part comes yesterday, but I didn't solve that. Well, I have solved that but not uploaded that. So you can read the description and understand the question by yourself, but I'm going to show you how it is going to be done. Now what we have here, we are trying to reach the bottom right corner of a grid as quickly as possible. So but there are three unique constraint. Okay, because we have constant. So what we do here, we can't enter a cell before we move our time with row and column, which means we may have to wait at the current cell until the move is allowed. So alteration move duration will be done there, and the time it takes to move changes depending on how many moves you have already made. Okay, so the problem we can say that not we say, but we are going to use here a technique of Manhattan distance, which is the total number of steps to take the reach or the target if you can only move up, down, left or right, is just the sum of the horizontal and vertical distances between 2 points. For example, we suppose we have 0 comma 0 and 0 comma 0 to 2 comma 3. Then what it will do, it will just sum up 2 comma 3 is equal to 5. It will not go to this 0 plus 0 and then provide 0 but then maximize. Just ignore the 0. Okay, so we use this as a heuristic in a star to estimate how close we are to the goal. It helps to guide the search. Now let's jump into the code. Code is going to be little bit sorry guys. So let's just make our class. We have to make our class state. C should be small. Yes, class state. We will define our instructor in our Python init self x comma y comma g comma h. This is our constraint, and you can say parameters also. Self dot x is going to be x, and like that we're going to say self dot y is going to be self dot y, self dot g going to be self dot g, and h going to be self dot h. Now the x is going to be our row, and this going to be our column, and and this going to be our cost so far that we calculate, and this is going to be our heuristic. Okay, now we define our constructor again, name lt, and self other, just return self dot g plus self dot h. If it is less than, other dot g plus other dot h. Now let's go into our function. Now what we do, we define r comma c is equal to length of our grid and length of grid column 0. After that we define our goal x and our goal y, not goal y, and that will be row minus 1 and that will be column minus 1. Now the cost we define as float of infinity, load of infinity that will be multiplied with column for dash in range of row. And now the cost is 0 will be defined as 0, so that's that, and the moves will be 0 multiplied with column, for dash in range with our row. That is going to be our move, and the PQ is going to be our state of 0 comma 0 comma 0 comma self man at 10 0 comma 0 comma 0 do 2 0, and then our goal x comma goal y. Now what we do, now we check if if PQ exists, while PQ, then the current will go to our heap, and then we push in our heap our PQ, and x comma y comma g will be current dot x comma current dot y comma current dot g. There will be dot. Let's make some space here, so it will be clear for you guys. Now we check if our g is greater than our cost of x comma x x and y, and then if that the case, then we continue. Then we go on and on. If x is going to equal to the goal of x and y is going to be equal to the goal of y, then we return our g, the cost so far. And now for dx comma dy in our 0 comma 1 0 comma minus 1 and 1 comma 0 and 1 minus 1 comma 0. Now these will be all our grid, and now we define nx comma ny is going to be x plus dx and y plus dy. If 0 is less than equal to nx and less than to a row, and 0 is less than equal to our column, not column, ny, then our column. If that's the case, then we make step is equal to 1 if moves of x and y is divided by 2 equal to 0. Means if the moves are even, and the weight we define as the maximum of g and grid of nx and y, and the new weight, new cost so far defined as a weight plus our step. Now we check if our new cost is less than cost of nx and ny. If that's the case, then we update that the cost of nx and ny is going to be the new g, the new cost, and the moves of nx and ny is going to be moves of x and y. Now the h will be self. Now we call h will be defined as a self of Manhattan that we defined above, and the parameter will be nx and y and goal of x and goal of y. Then we push that heap q heap push, and we push pq and whole state nx and y, new cost, and our h and h was the heuristic. Now if we don't find anything, means if we don't find our answer, then we return -1 for the base case. Let's define our Manhattan with self x1 y1 x2 y2, and then we return absolute of x1 minus x2 plus absolute of y1 minus y2. Now let's run this lengthy code and hope that work. If you don't make any mistake, invalid syntax. So guys, there are some mistakes that are not that big, but mostly typos, and one major mistake. There are some mistake guys, but mostly typos that we will fix. As we define our state as a capital letter, then it will be fine. And also there is no grid. I forgot to see the, because I have a habit to define graph as a grid most of the time, graph questions, right? So because of that, let's make move time. And what we do, there is no pushing, there will be popping. That is some critical, but not that much. And also I forget there should be comma, and with the if statement comes else too, not else too, but else also come with that. And the moves will be added by 1 also, and this grid will be move time. And I guess we are good with that. Let's run the code and hope that works. And see, every case has been accepted. And for you, I guess you can see the whole code. From we defined our state, and then in state we define our column, row, cos of r, and our heuristic h. Then we define then in the minimum time to reach we define our row and column, not defining but getting the length of it. Then our goal with r minus 1, c minus 1, then the cost, and then the cost of 0 0 we defined as 0, and the moves and the pq. Then we then if our pq exists, then we then we pop from the our heap, and then we define our x y g as current of x y and g. Now we compare, and then the working going to be done. So if you like my video, if you like my code, then you can subscribe my channel, comment, like and share. If you want more coding questions, you can visit my channel. I have made playlist for companies specific coding interview questions. You can also access that. And if you have any doubt, you can ask me on the comments. I will answer. Thank you. Let's submit this code. I forgot to submit that. Sorry for that, guys. You can see we are getting okay complexity, and it is somewhat between our this, but we are getting good complexity. It is a more optimized approach than our Dijkstra plus shortest path. So that's that. So thank you.